one. Ashley, which one of the following equations represents the dissociation of strontium nitrate? B. So for all of these and around the room, what I'm looking for is that you can divide it properly and you can balance it correctly. Deliberately pick these because some people want to separate them in the wrong spot. Use your table of polyatomic ions. Dissociate the following. So the difference between a dissociation and a hydrolysis equation, let's go with x squared and then do
just xy equals x plus y. No.
Dissociate both of those. And next, Ella.
I'm a bit lost. I don't know.
Well, I'll come back to you for that one, and I'll pick someone else to do the second one. Andrew. Second one.
Dissociation.
Yeah. Okay, hold it. I'll wait a moment for you to finish it. Don't
I have to get
glance
this.
at Glebs. Glebs, you can help him, but don't just show it to him.
Okay. CA4 plus XO plus.
CA 4 plus plus
X. O. 3 minus. Yeah. Right?
This is close. You did something here with the 4 though, and I think I see where you did that. You took this 4 down here and brought it up, right?
Yeah.
But if this had a 4 there, it would have brackets around it because it's two things. So, knowing that, how would you correct it?
CA plus 1.
What's the charge in calcium?
Oh. 2.
2.
And then XO 6.
Why 6?
Because you times by 2.
You times what by 2?
Oh, it's just 3?
If this is 3, that would go up there. Yeah, that would be minus 3. But the XO, I was just waiting for you to put the 4 back too,
Oh.
because it's part of the actual compound. You may have considered that already done. Ella, first one?
X like plus 3 plus y minus 2.
Okay, balance.
What's your balance?
Balance. Andrew, balance this one. You're just missing some balancing as well.
C.
How many calciums are on that side?
3.
How many should be on this side?
Oh. 3.
Yeah.
2x and 3y. What's your result?
Yeah.
What happened to the +2 charge on calcium in the second one? Like, why did it go to the XO4?
Yeah, it just disappears.
Has to be
Oh, hold it. This has to be -3.
That's what I'm saying. XO4 is -6.
When you were saying 6, I thought you were referring to down here because that's the number I was waiting for. So this has to be -6 because that gives 3 of those. That's a big X dog. Okay, I think you need a warm up. Don't write this on this page. I'm just going to write. Just need a list. Give me a randomized list. That looks good. Get a pen. Go to the board. And this is not in pairs, this is individual. Dissociate. And
Are we just dissociating?
just dissociating them. Put in the correct charges. And balance. What's another good one? This even. Pardon? Oh, okay. Yeah, sure. Grab a pen. We're just dissociating these in the board. Well, the interesting thing is that you did it correct for the carbon.
Oh, so
Is that what you did with carbon? Also, check your charges. Double check your charges. There are some charges you should just know. You also have your table of polyatomic ions. Josh?
Yeah.
It's not in pairs, you just grab a pen, individual. There you go there. Okay, did you figure it out? Oh, nice. Do you check your charges? You have to check different charges than Tio. Tio's fixing it. plus 6, that's minus 6, so the whole side's 0. This is also has a charge. But how many lumens are on the side? 2, 3, 3. So numbers wise it's balanced and charge wise. Yeah, I'm going to have you do the hydrolysis right after. Pardon? Oh no, completely different ones. Half of these don't make sense as hydrolysis. Charges. And you drop it to these 4. Where's 4? 3. 3. Okay, that's one. And you put 3 in front. But CO3? CO3. They get kept. Unless it's in brackets, they get kept. Is this one of the ones? No. Okay, as long as if you're not done, that's fine. And have you stop there and just come around and have a quick look. I'm going to erase these examples off. What mistakes did I make on my equation up at the board?
You did bring over the 3.
There's no charge, so we need charge and
The 3. Like
the 3 down here. So in looking around, 2 most common errors: forgetting a charge, and putting the 3 there. I should have also made this a 1 in order to try to honestly do it. First column +1, then +2. All the old charges you knew from last year, you need to keep up for this year. You have a table of polyatomic ions. Just go back, review that a little bit, and make sure you're just making that consistent for this next section. It will be handy to have that going quickly, because you're going to have to look at a compound, or you're going to look at a compound and then very quickly divide it into its parts, figuring out which side needs hydrolysis and reacting with water. So you need the correct compound and the correct charge. So hydrolysis is something like you have NO2 minus, and you undergo a hydrolysis. So the hydrolysis part is you react it with water, hydro, and then it splits. The water splits. Half the water goes here, and the other half of the water goes here.
Is it always at equilibrium?
Hydrolysis, all the hydrolysis you're going to do will be equilibrium equations, because they're all weak acids or weak bases. So, what kind of compound is this? Weak acid or weak base?
That's a base.
It's a weak base. So, when you do a hydrolysis, you're going to make its conjugate weak acid. So, let's say you have, well, the next one's going to give you an example. So, why don't I not do that? Why don't I have you do a few up here? Table. React the following in a hydrolysis. Let's go for, we did an O2 minus, so let's go with HCC. Oop, that's way too many C's. HCO minus. Nope. No amphiprotic for you yet. And okay, once again, individual. Find a spot on the board, erase your old work. I want to see them all. Right.
There's this hydrolysis?
Yep. Yeah. I am adding one more. The last one's a trick. I'm just going to tell you the trick. The very last one's an acid. So
Wait, what's the first one's an acid?
first one is not an acid.
Oh,
I should not have put that one there because I didn't want to confuse you with an amphiprotic. Hold it. Is the first one an acid? No. In this case, it'll be a base. I didn't mean to put an H1, so I will tell you that one's base. That one's acid. All the other ones you should be able to figure out.
The second to last one is amphiprotic.
No.
Why not?
That's what I'm going to ask you. The second to last one you can actually determine. If you look at if you find it on your table, you might. That's the easiest way to figure it out. The top word that looks like Bach is saying base.
When you say it's an acid, something like that.
Yeah, because I realize I'm doing all bases because that's the most common thing that we'll see. But acids can also undergo hydrolysis. You just react with
How do
water.
you tell if it's an acid? If you just have
Well, HF cannot be anything else. It's got a hydrogen, it's not going to accept another hydrogen. So H2F plus is not something that would happen.
how do we know that's not important?
Have you seen an acid that's plus? There's only one. It's NH4 plus. And it's got nitrogen and it's got a lot of lone pair electrons to accept it. That's the only one. All the other acids have H something.
But, okay.
Yeah.
Well, HSO4 minus 1.
But it has a minus charge. So if they have a minus charge, then maybe you can accept another hydrogen. And if that was like HS minus, yeah, that could be amphiprotic. But HSO4 minus can only be one of them. And it's because that one is on your table twice, and one of the places it's on will show you why it can't go the other way. I put it on there so I can talk about it. You could also just take a guess and write it and see whether or not you're right. HI, SO4, those look good.
When's that acid?
Good.
No.
No?
Yeah.
Yeah.
It's a strong acid though, so this is a strong acid. So
Right.
It would be a one-way arrow.
Which way would the one-way arrow go? Yeah. So is that the correct thing to write?
Do I have to switch it?
No, you have to write a different equation. That equation as written. All you want to write them all in the with that's the reactant. So that has to be it.
Yeah, but okay, that's the reactant, but it doesn't. According to this, it doesn't react.
According to that, it can. You just pointing in a way that makes it so.
It's an acid reaction. It's an acid reaction.
I'll show you.
Is it this?
Aha.
Or to figure out which one's the strongest. So it's an acid.
Right.
You said it's a base.
No, I said you should be able to figure it out. That's just me trying to be clever. Maybe it didn't work. Oh, I forgot to put the arrow on. Okay. Looking around, I didn't actually see you in one step. Your equation writing got much better, so good practice at the beginning. Looks like everyone got that one. Looks like everyone got. Well, I'm sure check your own because there could be a few, and I'm not wearing the correct glasses. But as I was going around, that one's good. I see a few around that don't have this reaction. What you have is that you've reacted it and you made H2SO4. Aha! You fell into my trap. Oh. That wasn't fair. It really wasn't. But the reason it's cannot go that way for someone who hasn't figured it out, who got it wrong, go to your data table and look up where HSO4 minus is. And one of those reactions is not like the others. Which one of these is not like the others? Do they still do that on Sesame Street?
That's a Taylor Swift song.
Yes, because we watched that.
That's the what?
A Taylor Swift song.
I don't think Taylor Swift was singing in the 70s.
Yeah. I'm not talking about this song.
Okay, you have to sing what's the Taylor Swift song?
One of these things is not like the others.
That's Sesame Street.
No, it's not.
Yeah, they would have 4 people, and they go, which one of these is not like the others? And like 4 of them were orange, and one of them was red, and they teach you your colors.
You said one of these things.
Yeah.
No, Sesame Street says which one of these things is not like.
I clearly need to start listening to Taylor Swift
I think
if she is singing the songs of my childhood. Okay, now you've had time to look. Someone who didn't get it correct, what's different about those 2 reactions?
One goes 100%.
One of them goes 100%, and the one that goes 100% is this one, and it goes that way. So that reaction cannot happen. So this, and we did this way back when I introduced amphiprotic. I said this one will fool you. It cannot be. It is only an acid. It's the exception. It looks like an amphiprotic HX minus. It looks like it, but it's not. It is not amphiprotic. So it can never act as a base because you cannot make a strong acid from its conjugate weak base. You have to make strong acids other ways. You make hydrochloric acid by bubbling chlorine gas through water. You make H2SO4 by reacting two different ionic compounds together. You can't make it from bases. Okay. Oh, anything that has this structure is more likely to be amphiprotic because it can attract a hydrogen or give one away. So you'll notice, like this one could have been, I didn't see that I had done that, and then Nick asked, oh, is this acid? And later on I'll teach you how to compare the Ka and the Kb, and whichever one's bigger is actually the one that's going to be. So it turns out that one's actually going to be a base. But for all the other ones, they don't have a hydrogen, so they couldn't be anything else.
So HX minuses are usually...
So this is unusual because it can't be amphiprotic. It looks like it should.
So that's an unusual case?
Yeah. So if I gave you HCO3 minus, can that undergo hydrolysis and be an acid? Because there's a likely reaction and there's an unlikely reaction. Do these two. In that I'm going to ask someone for a product and then I ask someone to give me the other product. For the first one, Nathan, what do you want to make?
What do I make?
Yeah, what is one of the what are the products? Just like you were doing now.
You can get H2CO3.
Right. And then if you do it that way, what's the other one? So if you do
Do it the other way. You would get.
no, don't do that one. Just this and
OH.
OH minus. Excellent. Now, react it the other way. Nicholas.
CO3 plus H3O.
Yeah, don't drop your charges.
H3O plus and then 2 minus on the CO3.
Perfect. Awesome. And both of these are legitimate. The only thing you would do is you'd look up the Ka for this and compare it to its own Kb. And then that would tell you, whichever one's larger would tell you the one that it's more likely to do. But they can do both. And so if you put this with an acid, it'll do this. And this is why if you, and if you put it in with a base, it'll do this, you'll get carbonate. If you put it in with an acid, it'll make this, it'll make hydroxide and force this.
I'm just confused about the HSO.
The HSO, oh, and if you put in, okay, let's do both conditions with this then. So Andrew, you're the one who just said you're confused about the HSO part, right? So give me one of them.
Give you one of them?
Yeah.
Okay. SO4 2 minus plus H3.
Yeah. And this is the correct one. That one works.
H3.
H3O plus, thank you for correcting me. And what would this one then be?
That'd be H2SO
Yep.
plus OH minus.
Plus OH minus. Now, look up H2SO4 in your table.
Look up H2SO4.
Look up H2SO4. Where is it?
High, like strong acid.
It's strong acid. But Andrew's asked the question 3 times, so I want him to look at it. Everybody else look at it too. You can look at it right in gloves. I'll give you a question in just a moment though.
It's a strong acid. Yeah, it's a strong acid.
Strong acid, which way does it go from H2SO4?
It goes right.
Yeah, well, it goes towards it. So if this is on this side, which way would this reaction go?
Oh, it would go
Yeah, and only that way. It's a one-way arrow. So this reaction can never happen. Does that make sense?
yeah.
Because once you make, it just falls apart. It just the energy and the entropy mean that can't happen. Good.
What about the first one? Where,
This one?
HCO3 is reacting with water.
Yeah.
HCO3 can't act as a base with water. It's more acidic.
HCO3 can't react as a base. Yeah, it can. Well, it can.
But it's more acidic. So So wouldn't the strong?
Oh, I said in both. You can compare the Ka and Kb to see which one it will actually do in neutral water. But if you, for example, you put this in with another acid, it can make hydroxide through this process. So it will act as a base. But there is one that it will naturally do. And then you can it will actually do kind of both. And you can calculate from the Ka and the Kb what the resulting pH will be, because it's a little bit more complicated than just a straight acid or a straight base. Okay, hydrolysis of NaNO2. Now that we've done dissociation, and now that we've done hydrolysis, what are the two ions in here?
Plus and minus.
Plus and minus.
Well, Na is plus.
Na is plus. So we got Na plus and NO2 minus. Which one of those can undergo hydrolysis? NO2 minus can undergo hydrolysis. What about Na plus? Shaking your head. Good. Right instincts. Why?
Because it can't donate a proton.
But it could accept one.
No, because it's positive.
Close your eyes if this would confuse you. But I can write the equation. It's easy.
Is it soluble?
It's 100% soluble, which is what you'd need for it to react. What is there an acid or a base that sodium belongs to? The most common base in the world? NaOH. And which way does that go? Okay, that should probably unlock it. What kind of arrow do you have on this? Singular arrow, which way? We go to the right. So again, we have a one-way arrow. So all the ions from strong bases, sodium hydroxide, potassium hydroxide, lithium hydroxide, calcium hydroxide, strontium hydroxide, all have one-way arrows. They cannot, they're always spectator ions. So those are spectator ions. So looking at it, part of it is cutting it in half, figuring out your two types of ions, eliminate the spectator ion, and write the hydrolysis that's left. You can have two that both react, but most often you're going to get a sodium or a lithium or a potassium or a strontium or something that will cancel out. Okay? So the plus one and plus two metals you can generally assume aren't going to do anything. Oops. Ignore plus one, plus two metals most of the time. And you'll get a feel for that as you do more reactions. You'll feel the vibe. Sodium has a particular vibe. Okay.
T1, T2 metals.
Plus one, plus two. T1, T2. That's okay. You remind me of a somewhat inappropriate but funny thing. I saw a friend of mine was wearing a necklace, and one of my other friends, who grew up rather differently than they did, asked where could they get a necklace that had a little T on it.
Oh.
And then we had to explain an entire cultural history to them. Oop. Good. Everybody got it? I don't want to pull out the reveal too soon. So you should have something like that. Good. Good, 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 good. Do it for this one. Identify the spectator ion first. And I want to know why it's a spectator ion. What? while you're doing that, I have some really, really, really upsetting news. On Friday, our class is normally third block and has been canceled due to the gap.
That's so sad.
Oh, awful.
But tutorial isn't canceled. So I'm saying the tutorial is F block.
I already made plans with English.
And you have a quiz in Friday in tutorial.
How are you gonna do that?
You're joking.
That's not legal.
I'm an IEP, I got extra time.
Okay.
Wait, are you? Yes, I was!
Wait, hold on.
No, wait, no, I can't do that. I already made plans with
No. Your quiz. Because I want to write it down, we're not going to erase it. I haven't finished marking the other quizzes, and I'm sorry for that. Weekend turned out to be too busy. I noticed some of you put down good but wrong answers for JKL. You were already putting in ice tables and KAs, and it was like, we hadn't even done that for the quiz yet. We just did it in class, but it was on the quiz. And so there's a confusion between reactions that are like this, that are one way, that don't require and just have it cancel out, and reactions that are like this, that we're doing right now, that are hydrolysis, and are two-way, that require a KA. So it's only going to be two questions. It's going to be a L-type question, in which it's just a straightforward one-way reaction, in which you have to calculate the pH, and you don't need a KA, and you don't have an ice table. And it's going to have one ice table question. So it's going to have an L question and an M question, and I want you to tell it apart.
You don't even want us to do it?
No, I would like you to do it.
No, I mean, like, do you want us to, like, do the question? Or do you
I want you to do the question, because then I can tell how much you can tell it apart. But there'll be easy versions of those questions. I'm not going to give you really hard ones. There's a straightforward ice table and a straightforward, 1.5 moles per liter, 150 milliliters of 1.2 molar HCl is reacted with 200 milliliters of 0.5 molar NaOH. What is the resulting pH? And then you have to go, I just get the moles minus the 2 and do that. I'll make sure the numbers are easy.
Wait, are you actually serious about a quiz on Friday?
Yeah.
Yeah, but he says, like, 2 questions.
It's 2 questions. And
Wait, it's 2 questions.
if this is deeply upsetting for you and you're like, no, okay, I'm not going to penalize you if you don't show up to my special tutorial class. I'm just going to say that I'll know that you don't love chemistry, and I will color my entire view of you for the rest of the year.
Hey, wait, can you go over the 2
But if you know me from the house, you know I also forget everything. So,
Can you go over the 2 questions?
you remember the questions from Hebden that had like this amount of acid and this amount of base? What is the pH?
Yeah.
And then you just had to figure out the moles and minus them.
Like, it gives you the concentration.
It gives you the concentrations. That's an L question, and you usually have to calculate pH. There's no ice table involved because they're both strong acids or strong bases.
Right, you just use, like, the...
Yeah. Yeah. Or like on the quiz, for some of them, you had a question that was like, you have so many molars of calcium hydroxide, and let's say it was 1.2 molar of this. It would ask, what is the pH? And all you had to do was this. And if this was, say, 0.2 molar, then this would be 0.4, and you go negative log 0.4, boom, you had the pH. Like this, actually,
Like, you use PO, it should be the negative log.
yeah, I might even just do this one, because that's even simpler.
Yeah.
And I just want you to tell the difference between them, and then quickly do them.
Okay. So one is an ice table, one doesn't.
One is an ice table, one isn't.
Are the quiz marked?
Pardon? Are the quiz Marcel?
Marked. Well,
Marked.
yeah.
No,
Okay.
I've said like 3 times in the past that I was sorry. I haven't marked it yet.
It's fun that
I did.
Yeah. I was on duty both days in the house, and we went to Victoria, which was fun, but I didn't end up getting much done.
Do we have an idea of when?
Now, again, I'm not going to mandate you come to it. I will say if you come and do it, and you do well, it will be helpful to you. If you don't do well, I'm not sure it doesn't harm you, but I think this would be a useful thing to do. The other class gets their class this week, and you don't. And I know that wasn't deeply hurtful right away. But as far as I can tell in the schedule, that missing class is never made up. So you will just be further behind the other class. We're going to have to go a little faster. This means I don't have to put the quiz in another class, and you can just get on with it. Yep.
If we do really well, can they be worth 100% work rate?
No, but I appreciate the hustle. Appreciate it. Okay? Appreciate it. So, I also hate tutorials. But anyway. I mean, I like that you have them and you can come get them. But how many of you use every tutorial and go somewhere?
Bro, it's called half.
Yeah, exactly. My proposal is that we take all the tutorial time, we just put it back in class.
Yeah, you should be
Put it back in there. and we make the classes 45 minutes long.
Well, what if we just got rid of Saturday classes?
Yes.
And then like we just have sport at like 10, 11 o'clock.
I am someone that if you just told me this was happening and I had no choice of it, I mean, great. I get more of a weekend, even if I'm on duty in the house. I don't have to come in here and teach. It would be disastrous for the school. As if you graduate and you come back 10 years later after that happened, it won't be the same school.
It's gotta be hurting their admissions. Like no way. Like people are like, "Ooh, Saturday school, I want to go here."
You came here.
Yeah, I didn't choose to be here.
No, Mr. Johnson has assured to us everybody chose to be. Yeah, and you weren't made to, you got to. We have seen schools that are similar to ours make this policy in the past. As you can imagine, roughly 80% of the teachers in the school have been lobbying to get rid of Saturday classes since forever. Because even if you're an adult, who wants to come in and work on Saturdays? Every school that's made that change in a primarily boarding school environment, if you knew you only had sports or fine arts on Saturday, no classes, what would you do on some weekends?
Relax.
Vibe out.
Sleep.
Yeah.
Catch a moment.
How many people do you know that live in Vancouver? Or could fly to Alberta in a weekend? When a third to half of your school leaves every weekend, eventually they stop planning weekend activities. When they stop planning weekend activities, the school culture on the weekends drops. Now there's even more of a reason to leave. And soon it becomes a boarding school, but it's more like a day school where you live there for 5 days and you go home on the weekend. And then you tend to get less international students, and you start getting more local students who live like that where they can do that, and the entire flavor of the school, and you don't have really a boarding school. Most of the boarding schools that did that, their entire school culture shifted so radically that they're all working to fix it, and they wish they didn't make the change. And once they made it, how much would you love it? A lot, so they can't go back either. It's like locks on the doors in the houses. In that it's a change that seems obvious to be a good idea, but when you look at every school that's done it, it's a terrible, terrible idea. I lobbied.
Why is locks on the door terrible?
I lobbied for years to Mr. Johnson, and accounting anybody, like theft in the house is such a killer to the vibe. It only takes 1 or 2 people stealing all the time to ruin, everybody's trust for everybody else. So I want locks on the doors, really badly. Mr. Johnson travels a lot, and he went to a lot of different schools, so he started asking on our behalf, how can you implement this, what has happened? Every school he went to, it did it, regretted it immediately. Theft went up.
How does that go?
Theft goes up because it turns out all of you have friends. And you have friends that you want to have access to your room. So you make copies of your keys or your key cards, or you prop your door open, or you say, oh, it doesn't matter, pop in through my window. Like, even other friends inside the house, you leave the door open so they can go get your stuff. And now the doors are still unlocked a lot of the time, and because you have a locked door, the psychology is my stuff is safe, and you leave more of your stuff out. But who steals your stuff? Random, unknown people from other houses, or your friends?
I'd say it's a bit of both.
Every theft you've ever had in the house is probably from someone you know and you'd consider to be a friend. And back in the days when we could put videos inside of rooms, video cameras, we found that to be the case every single time we caught someone.
Video cameras inside like boardrooms?
Yeah. Well, I didn't. I had like a giant VHS.
That's like childlike.
No. Yeah. I didn't do it. In that I didn't put it in there without the person knowing. Here's how it worked. You come to me and you say, Mr. Neufeld, someone's stealing money from my room. And I say, great. Here's a VHS. It's hooked up to this little camera. Here's a 16-hour tape. Hide the VHS and take this little small night camera I can see in the dark and just poke that out from behind the hidden VHS. And when you want it to record, press record. And if you're in there, press stop. It's entirely up to you. I'm not monitoring the camera. I don't see anything. And so when there's a theft, you just bring me the tape and say, Mr. Neufeld, review this. So we go through the tape at that point. We caught multiple people that way. And every single time it was either their best friend or someone they knew really well.
Why don't we bring that back?
It's actually illegal in Canada now. If you have a camera, you must post a sign saying that you have one.
That's,
Well, you know when you drive in our entrance, there's signs that say there's a camera here.
yeah.
You'd have to do that in your room. So now you can't. I mean, you have computers and webcams. There's lots of programs you could set up where it does it yourself. Like we don't need to provide this anymore. I mean, it would also be illegal for you to do it, but you know, you're underage, and if you got the evidence, but it's always your friends. And so the theft never went down. And then, what does a grade 9 do with their key or their key card? Lose it. And guess who else loses it? All the grade 12s. Everybody loses their card. There's no difference between grade 9 and everybody else. And so they are constantly replacing them. It's as bad as the sign in the dining hall, but just so much worse. So at that point, I gave up trying to ask for it because it was clearly a bad idea. The next one is cameras in the hallways. Everybody wants cameras in the hallways. And they found out all the schools have done it. Like, please, if you can avoid it, don't. Because all the house parent, like myself, would then doing, you just spend hours watching tapes, and you eventually end up like the security guard with multiple screens, and you're just watching them all the time. And that, yeah, it's creepy, it's invasive. You don't catch very much, but everybody's always upset because you should have been able to, but yeah. So then everything becomes recorded all the time. And they all say that the school took a turn for the worse, the house culture, people didn't trust each other more when there were cameras. So, which one of these is spectator iron? CL. Why?
One way.
Pardon?
One way.
One way. From?
HCL.
ACL. One way reaction. Taz? This reaction.
HCl.
Yeah, it's on the top, so that means it cannot go backwards. So there's no hydrolysis for it to do.
If it's at the top, it can't go backwards.
Yeah, if, on top and on the right.
HCl is not allowed.
So all the conjugates of the strong acids are all spectator ions.
Over to C.
So if I was to go here, all of these, no hydrolysis. Because you cannot take Cl minus plus H2O and make HCl. Because HCl would immediately go that way.
Can you put an Na be on the other side when it's at the bottom? So wouldn't that still be hydrolysis?
If you put Na in here, these ones, no hydrolysis. Because for bases, the arrow goes the other way. So NaOH would be on this side. Because these are all written as acids. So to do that, we'd have to go NaOH plus H plus and makes H2O plus that. But
Wait, Mr. Dupont,
yeah.
how can't NH2 have hydrolysis? Because it can accept NH plus.
Oh, hydrolysis for this direction, acting as a base. NH2 is incredibly reactive going the other way. NH2 minus plus H2O. What would that make?
NH3.
NH3 plus H minus. And then H2 minus.
Yeah, so shouldn't that
Hold
be-
it, hold it. Did I do this the wrong way around? Yeah, because I circled at the same time. I said it takes place on different sides, and then I kept circling on the same time. Thank you, Tia. Because it's actually these cannot become, go this way, acids. They can't be acids. And these cannot be bases. So no hydrolysis this way to make hydroxide. No reacting the other way to make H3O+.
But that's what I'm saying, like if you have Na, it would be on the right side, so it would still go back.
I'm just going to do it this way so I don't get confused. What kind of arrow do we have with sodium hydroxide? One way. So if it has a one-way arrow, that means you can't go that way. The only thing that possibly could happen, because this is accepting if it went this way, it'd be acting as an acid. It'd be sopping up hydroxide in some sort of reaction. So it'd be acting as an acid. It can't act as an acid because that would be the opposite reaction. Now, it would be possible maybe for it to act as a base. And I'll also show you an exception later because the +3 metals can do it through a completely different mechanism. Now I've talked about security and Saturday classes. Some of you may find yourself on the board in a number of years, so those decisions might be yours. The board got rid of grade 8s and all sorts of things. What are the reactions?
Who brought them back though?
They brought back grade 8 no grade 8 borders, and they brought back a couple grade 8 borders, and then we went, oh, that's why we don't have grade 8 borders.
Why though?
Yeah. Why?
Yeah, why?
They're too young. North American kids don't do well in grade 8 in a boarding school for the first time. If we got all our kids from the UK, it'd be fine. They've been in boarding school since like grade 2. I still remember Will Pickle standing outside the house, glaring in grade 8 at all the other, they're all sad because their moms. And he's like, what's wrong with these kids? He's been in boarding school since kindergarten. But North American kids, we find, they would literally hide under their beds and refuse to come out sometimes. It was just, it was really sad. Yeah.
Wait, is it true that you were house parent for a satellite house 40 years ago, or like 20 years ago?
Yeah,
What was the name of the house?
Watson House.
Where was it, on campus?
It was a little, about where the dining hall now stands. And the health center was right next to it. It was a portable with a bunch of rats underneath.
But what was the point of Watson House?
Just extra people. You're distracting me. What? Tell me the answers. Tell me the answers. Right here.
What?
What are the two products?
Oh, couldn't tell you right now. Is it OH minus?
Is this more likely to give off a hydrogen or take another hydrogen?
Give off a hydrogen.
If it gives off a hydrogen to that, what does that become?
H3O.
There you go. Plus
NH3.
NH3. Excellent.
Wait, but that's not the net ionic, right?
Actually, technically it is. There's nothing in there that can cancel. So, yeah. The ionic equation, Taz,
Yeah.
the only difference was that you would put something like chlorine in here, like we had up here, and then you get this and chloride. But we already eliminated the spectator ions, and so, yeah, it does become the net ionic.
Wait, can you go over how you know it's a...
Net ionic? We pre-eliminated the spectator ion that doesn't
How
do
do
anything.
you know that was the spectator ion? Because it doesn't have...
It doesn't do anything in this reaction. It'd be present here, and it would just dissociate 100%, and then it would be present here, but it would just dissociate 100%. It would be on both sides, and you'd be able to cancel it out. I now have, because of Watson House, why am I picking up? enough time. Oh, you got it. Yeah. Okay. Hydrolysis the reaction there's no predict acid and basic or neutral. Do you have a for these ones, I would like you to predict your own. Pick a strong acid and strong base, react them together. Pick a weak acid and a strong base and react them together. Pick a strong acid and a weak base and react them together. Your choices for each one. Because of Watson House, I actually have grand students. Chris Baker was one of my students. He's a grade 11 Ellis boy. So we had 2 Ellis boys in Watson House. They lived there, but they did like inner house near like day students. And we had 3 Privet boys. Chloe Baker and Liam Baker and Ellis and Mackenzie are his children. So I've got grand students.
But like, was it like dirtier compared to the rest of the houses?
Dirtier?
Yeah. You said that's-
No, fantastic.
it was well,
I lived on the top floor. They had 3 bedrooms on the bottom, so they had roommates. So from their perspective, way back when, before really good laptops or streaming, they had the TV to themselves. And we would do prep on the porch every night and watch the sunset.
That's actually dope.
So nice. I would yell, sign in, and they would yell, boy 1, boy 2, boy 3. Not their names, literally boy 1. And by the sound of their voices, I knew they were all there, and then I'd close the door.
I'm so funny.
I was told as a house parent, I got $2,000 per month to spend on them for like house outings. So like I bought them like a huge amount of groceries for the first while. And then I was told I'd spent their entire years plus right away because they didn't have $2,000 per month. That was the big houses. They just mistook it. They had like $50 per month. So they at least got a lot of food.
Wait, what year was this?
99 to 2000.
They get now.
Wait, how long were
Like
you the
5,000
house parent for?
The budget is such a mysterious beast. I have no idea. Every time I ask, it's a different number, and I could ask the same in the same year. Sorry, Tess.
How long were you the house parent for?
That only lasted 1 year.
Memorable year.
Memorable year. And then they took everybody out. They ripped it down shortly thereafter. They moved the portable, and they're building more buildings. Before that, if you talk to old people, it was called Bell House, and girls lived in there. Similar, they would be associated with a larger house. For a long time, we didn't have as many female houses associated as we had male houses. So to increase the number of girls on campus, they had all these little houses on campus. They would just put a house parent in and fill them up with as many girls as they could to try and boost the numbers until they could build all of the girl houses. And then the person who ran Bell House, Carrie Bell, she still works at Shawnigan's, left.
She's still like around.
I think so. She's French. And they were like, well, they didn't have a female house parent to take it over. And they were like, you're new and out of school. You don't know what you're doing. How would you like to run a house? And I was like, would I? And so they put boys in it just for fun for 1 year.
That's cool.
And then Mr. Snow would park the snowmobile there.
You got a snowmobile?
His Trans Am. His Trans Am. Did you just say that's a snowmobile? You don't know what a Trans Am is?
Okay, I know what time it is.
Oh my
Oh,
god.
wait, actually. Okay, but you can.
He has that. What? You see? Yeah, that's
Oh, it's that great.
Oh wait, he
Yeah.
still has it, yeah.
Mr. Snow had that with the bird on it. And when he first brought it here, it ran and it went fast. And then eventually he just parked it because it broke, and then it slowly deteriorated for years.
Wait, when did you come here?
Pardon?
What year was it when Mr. Snow came?
99. Same year as me. Staff still confuse us. I get called Mr. Snow by older members of the staff because we both arrived at the same time and we look so much alike. Yeah.
No, I know what I'm doing.
And then he was a teacher, and then eventually became the assistant to Rogers House. And the next year I became the assistant to Privet House.
History books.
Okay,
With Mr.
vote for what strong acid?
I did.
HCl.
Hands, pardon?
HCl.
HCl. Someone else for the strong base.
Oh, H2SO4.
That is not a strong base.
Oh, it's
Hands, I'll go for the first. No, you already had one? Yes?
Oh, wait.
No, you can't just have OH. Strong base. The whole thing, yes.
NH2.
NH3.
NH2 minus.
NH2 minus would work, but please no.
NH3.
Why not?
What?
No, that's weak.
Yeah,
Wait,
it's all that.
why not NH2 minus?
Oh, you can. It would have to be NaNH2 minus because you need a positive charge with it. I don't want to do that one. No. The classic ones.
That is a classic. K2O.
What?
K2O.
Yeah, this is a strong.
K2O?
Wait, no.
No. KOH. Thank you. Thank you. You are playing this properly. Excellent. All your strong bases should have hydroxide in them. Hydroxide. On that note,
Can't really make
So why can't you do NH2 or like O2 minus?
you can. I don't want to for this example. No. NH2 minus is a base you'll almost never see. You're picking it because it's on the table.
Yeah, that's
It's like when you watch a medical show and then people with all these weird diseases come in. If any of your family are doctors, have you ever watched those with your parents?
Yeah.
Do they know all those diseases? Really? So many of them are usually end cases, like they're incredibly rare, but you learn about them in medical school because they represent a certain class of disorder. So they're all the most famous cases. NH2 minus is just there because it's on the table. It's famous for that because it's not like the others and it has to go on the table. But you never actually use it, just like you never come across those diseases in a real hospital. When you hear hoofbeats, think horses, not zebras. And it's not lupus. Another strong base that's not KOH.
O2.
Stop that.
NaOH.
NaOH. Thank you. You are also playing this game properly. Another strong acid that's not HCl. HI. I like HI. It's underutilized. Weak acid.
HF.
I heard HF. I didn't hear what yours was.
Isn't
But-
HF strong as hell?
It's reactive as hell,
Oh,
but
never
it's not
mind,
strong
never
as
mind,
hell.
it's not.
Yeah. And then someone else who hasn't given me one, a weak base.
FeH2O.
No, God. God, no. Gleb, no.
NAF.
No, we already have F, but okay. Oh no, that it'll make nice symmetry. I'll go with that.
So why can't we do like AL in brackets H2O?
No, I don't want to write all that. You don't want to write all that. I could do it.
Do it.
No.
I believe in 4 minutes.
Where'd you find NAF?
You can
Where do you learn NH?
Andrew. F minus is a base
Oh, yeah.
on the table. You just put it within it.
This is for Gleb.
No, God! No, God, please, no! No!
I'm gonna have that at the ready now.
These?
Okay, take these. We have what, 2 minutes left of class? What? What did you say?
Let's do it, let's do it.
Yeah, yeah. Actually, what did I say? Because the boat's going to go in a minute and a half. So let's get you up. Go grab a pen. Go grab a pen. And do any one of them. First, you don't have to do them in order. Someone do the first one, someone do the second one, some group do the third one. When you're done, one of them, you can circle it. And if the bell has gone, you can go. Predict the products. What kind of the not dissociation? What kind of reactions are these?
No.
They're acid-base reactions. They're acid-bases. Why are you packing up? No packing up.
I'm just getting
Yeah,
I'm just getting my Nope.
I don't know, bus stop so.
Your charges are weird.
Tell me.
There you go. That's good. Do the next one.
Oh, I know you said
Well, the bell hasn't gone yet, so you can keep going while the bell's going. As long as you've done at least the one when the bell goes, you can go. But I want every last minute.
Oh, Mr. Noodle. We got it. I think we got it.
Okay, page 2.
Excellent. Do the last one.
Are you kidding?
You got 30 seconds.
You're joking. You said
30
what?
seconds. No.
it's
If the bell goes and you've only done one, yeah, you can go. But if you've got time. Oh, yeah. Thank you. That was a lovely class. That was a great start to the morning. I enjoyed myself immensely.